Hey there, and welcome. In this explainer, we're going to break down one of the most powerful tools humanity has ever created, the computer. I mean, we use them every single day, but if you ever just stopped and wondered how they actually work, well, that's exactly what we're going to dive into. So how in the world did we get from this, a super simple abacus for, counting beads, to this, artificial intelligence that can literally learn, create, and reason all on its own? It's one of the most incredible stories in human history, and it all comes down to understanding the machine at the very heart of it all.
All right, so here's the game plan for our journey today. First, we'll look at what makes a computer so amazing, its superpowers. Then we'll take a lightning-fast trip through its history, uncover the secret design that makes it all tick, see how it turns nonsense into meaning, and finally get the difference between its physical body and its digital soul. Okay, let's jump right into our first section, a machine with superpowers. Because trust me, the device you're watching this on right now isn't just a box of electronics. It is so much more than that.
So at its core, this is the official definition. A computer takes in raw data. We call that input. Then it follows a list of instructions to mess with that data. That's the processing. And finally, it spits out a useful result, the output. Input, process, output. Remember that. That simple little loop, it's the heartbeat of everything from your smartphone to a massive supercomputer.
And what makes that simple loop change the world? Well, it's these superpowers. It's got absolutely mind-blowing speed, doing millions of things in the time it takes you to blink. Its accuracy is pretty much perfect. It's got massive storage for, basically endless amounts of information. It can automate all the boring, repetitive tasks. Its versatility is insane. It's a gaming machine 1 minute and a movie studio the next. And get this, unlike you and me, it has endless diligence. It never gets tired, it never complains. These are the characteristics that make it so revolutionary.
Okay, so we know what it can do, but how did we even get a machine with these superpowers in the first place? Let's find out. We're about to take a super fast journey through the history of computing, from these giants that filled entire rooms to the sleek little devices we carry around in our pockets. Just look at this timeline for a second. It shows you just how fast things started moving. We're going to hit each one of these generations, and you're going to see how every single leap forward was really because of one single game-changing invention. And welcome to the first generation. This beast is the ENIAC, one of the very first electronic computers. I mean, this thing was a monster, powered by thousands of super fragile vacuum tubes. It took up a whole room, guzzled electricity, and got so hot it needed its own custom cooling system. Just wild. And then, boom, the game completely changed with the invention of the transistor. This tiny little thing replaced those big, clunky vacuum tubes, and that kicked off the second generation. As you can see with this IBM machine, computers got way smaller, way faster, used less power, and were so much more reliable. This was a massive step forward. But why stop there, right? The third generation took that shrinking act to a whole new level. Scientists figured out how to cram hundreds of transistors onto a single tiny silicon chip. They called it the integrated circuit, or IC. This made computers even smaller and cheaper, of course, but just as important, this is when we started to see the first operating systems, which made them a whole lot easier to actually use. And this is where it all starts to look familiar. This brings us to the fourth generation, powered by the microprocessor. That's basically an entire computer brain on one single chip. This incredible invention gave birth to the personal computer, the PC. And all of a sudden, machines like the Apple Macintosh here brought all that computing power out of giant corporations and universities and put it right on our desks at home. So, okay, they got smaller, they got faster, we get it. But what's actually going on inside? How do they think? Well, that brings us to our third section, the computer's secret blueprint. Because deep down, whether it's a tiny watch or a giant supercomputer, they all share the same fundamental design. And here's the secret, the key to the whole thing. Pretty much every computer you can buy today is based on this one single elegant model, the von Neumann architecture. You can think of it as the universal blueprint for how a computer's brain is organized and how it all works together.
To make this super simple to wrap your head around, let's use an analogy. Just imagine your computer is a chef working in a kitchen. I promise this will make everything crystal clear.
So this blueprint has four main parts. First, you've got your input devices, like a keyboard or mouse. Think of those as the customers placing an order. That order goes straight to the CPU, the central processing unit, who is our master chef, the brain of the whole operation. Now, our chef has two important parts. There's the control unit, which reads the recipe and tells everyone what to do.
And then there's the Arithmetic Logic Unit, or ALU. That's the chef's hands and tools. It does all the actual work, the math, the decision-making, the chopping and mixing. The chef uses memory as the kitchen countertops and pantry to hold the ingredients and the recipe. And finally, the finished meal is served up through the output, like your monitor.
Now, let's talk about memory, because there are two kinds you need to know about. First up is primary memory, or what we all call RAM. Think of this as the chef's countertop or your desk space. It's super fast, and it holds everything you're currently working on. But when you turn the power off, poof, the countertop is wiped clean. Then you have secondary memory, or storage. This is your permanent filing cabinet or your pantry. It's where you keep your files, your photos, your apps forever, even when the power is off. It's a bit slower to get to, but it's permanent.
All right, so now we know how the kitchen works. But what's the whole point of all this cooking? What's the computer's real job? Let's check that out in our next section, where we see how a computer turns a bunch of raw facts into something that actually makes sense.
This slide just makes it so clear. On the left, you've just got stuff, raw data, the numbers 32, 101, 95, and the name John. By themselves, they mean absolutely nothing. But when the computer processes them and adds some context, you get information. Suddenly, it's John scored 95 marks in room 101. Now those random facts tell a meaningful story. That transformation is the entire point of a computer. Okay, for our last big concept, we're going to look at the two halves that make a computer, well, a computer. We're talking hardware and software, or as I like to think of it, the body and the soul of the machine.
And it really just boils down to this simple distinction. Hardware is all the physical stuff you can actually touch, the CPU, the keyboard, the monitor. It's the body. Software, on the other hand, is untouchable. It's the set of instructions, the programs, the operating system. It's the mind, the soul, that tells the hardware what to do. The key thing is you can't have one without the other. They need each other to work. And that incredible journey through time brings us, well, right back to today and into the future. The fifth generation. This is where hardware and software are evolving together to create things that used to just be science fiction. We're talking about artificial intelligence, machine learning, and the really mind-bending world of quantum computing. All of it ready to redefine our world all over again.
So, I'll leave you with this to think about. The first 4 generations of computing took this technology from a single, massive room and managed to put it on every desk and in every pocket. The question for all of us now is, with the unbelievable power of AI and quantum computing on the horizon, what will this 5th generation do? Thanks for joining me.